Greetings, YouTube, friends, colleagues, subscribers, scientists, like-minded, all those on the greater endeavor for the greater good of humanity and more. Welcome to another shad0wburn3d broadcast. All right, we're going to do a mixed edition today, and this is to dispel the penny, quarters, nickels, and dimes phenomenon. As you can clearly see, that to start with, in glass, it is not sticking to the edges. It is able to move freely around in glass. That'll be the first thing we are testing, is does it move with something very smooth like glass? The answer is yes. So we have not broken the internet with glass. Pennies, nickels, dimes, or quarters. Okay, the next thing is now that you know within this glass that it's not sticking to the glass, it should prove the point that there is no sticky materials on this change. So what are we going to do first? First, we're going to set it here on this white sheet of paper, and we're going to pour it out here. And we're going to irradiate it with 1,000 watts of blacklight UV power to then observe if there's anything on this change. You can see that there are dirty particles on some of the change. So that will be illuminated with the power of UV. Okay, next. Somebody had asked me for a Band-Aid sample. As you can see, this is a generic Band-Aid Equate, right? Common, standard Band-Aid. I'm going to open this Band-Aid up in this package, and we're going to see if this Band-Aid is stained with anything. So for that individual that requested that, I made sure to get this for you today because I happen to have this on hand and in hand. Also, I figured while I'm drinking some water, I could say, what happens if we stick this bottle of generic purified drinking water in front of the black light? Is it going to show something going on the inside of the water that I'm consuming? I don't know. We'll find out. But I figured, hell, why not? Since we're going to be doing this dispelling of the penny wall phenomenon, I might as well do this too. And then I will give my views and perspectives on why the penny may or may not be sticking to the wall in some areas. So, okay. So let's start with this change first. And give me 1 second. I did get a special cloth here to make sure to wipe off the change before we perform the experiment here on a game room token on the wall. It sticks to my finger, but it's not sticking to the wall. And it's sticking to my finger because my finger, obviously it perspires a little bit. If I squeeze it really hard, yeah, I don't have enough there, but if I do that, yeah, it'll stick to my finger. But you can see it falls. So token doesn't have any copper in it, so that is not sticking. And let's get on to the next thing. Let's go ahead and dump the change out here. There we go, on a white sheet of paper. And let's fire up the 1000 watts of blacklight power here. Starting with side A, there we go. And now we will fire up side B. 1 second. Oh man, all right, there we go. We have A and B working. Let's go ahead and bring those in as close as we can here. That is a 8.5 by 11 sheet of paper. This is a 12-inch ruler, and you can see that the paper is much smaller than the ruler. Okay. The blacklight is definitely overpowering the foam, but let's start out with this quarter here. What do we see with the quarter? Not very much. We can definitely see there's stuff on it a little bit. Okay, that's a quarter. And there is the name on the wall. You can see down here the panels. You can see glass bowl here, gravity. Okay. And that is where I have my alias for this video presentation taped up on the wall. We're going to take this quarter and we're going to push it into the wall right now. Quarter. Okay, no, it did not stick to the wall. That quarter did not stick to the wall. What else is something that I wanted to test here? Let me turn these black lights off really quick. And let's get to this. Here's a lighter. There is the lighter on the ground. Here is a magnet. I'm going to pick the lighter up with the magnet. Okay, the magnet has picked up the lighter. I have shaken off the lighter with the magnet. Okay, now we're going to test all of the change here to see if any of it is magnetic. Nickel, nothing. Penny, nothing. Penny, nothing. Nothing. Quarters, nothing. Dimes, nothing. This penny actually has some debris on it. You can see it very close here. It's got debris. Okay. We're going to even use the dirty side and stick it to the wall. Okay, that did not stick to the wall. Okay, so magnetism, all of the change, nothing is having a reaction. I'm going to let the magnet sit here for a minute. Zero reactions. Zero reactions. Am I cheating the system? Here is the magnet. Here is the quarter. I'm dropping the quarter. Okay, we're not doing anything crazy here. But is this happening? No. So I think that answers this question. The only thing I have not done yet is done two last things, which is to open up the Band-Aid package. I'm going to do this with the 1,000 watts of UV power light shining into this to see, I don't know what we see here. And I'll do just a couple of things for fun, like this glass that the change was in. Just for fun, and we'll do this my bottle of water here. Okay, here we go. We're powering the lights back up again. There's A. Let's get back over here to B. There is B. B is not active. Okay, let's have a look at this glass. All right, nothing special about that. It's transparent, translucent glass, kind of like when we were seeing my fingers through all that stuff we were x-raying yesterday in the previous video. So that's what we have seen. There you go. How does this lighter look? Yeah, nothing special there. But you can see how dark it is because of the color and the material in there. Yeah, All right, nothing special. Okay, next bottle. What do we see? Let's get close. Just plastic. Obviously you can see all the dyes sticking out in the wrapping. Outside of that, nothing special about the water. Let's turn it sideways. All right, nothing special. Okay, let's look at the bottom of the Band-Aid. Okay, so far we are seeing through the Band-Aid package. Now before you couldn't see through it, but because of the blinding UV, you can see through the packaging. Not only can I see through the packaging, but I can see through the Band-Aids too. So yeah, you can actually see in there, you can actually see where the white part of the Band-Aids is. So now let's do the next part. Let's go ahead and take one out of the packaging here. Give me a second, hang on. 1 second, stand by. 1 second, I'm trying to see if I can do this without dropping the camera, but here we go. Hang on. Stand by. Stand by. Okay. Hang on. I got it. I think I got it. We're doing good. Okay, hang on. Let's see. Let's see what we got here. We are now opening the part with the white cotton that generally goes over whatever the wound is. So in here, it looks like you can see a little bit. No, okay. That's the reflection of the bandage packaging underneath, but I can see some discoloration. I'm trying to get in closer. You can see a little bit of discoloration in the material. It could be because there's an antibacterial in there, but you can see it. So is there a little bit of a applied substance in there? Yes, you can actually see that. What it is, I don't know, but it is coming through. Okay, so that answers that question. Don't ask me what it is, I don't know, but it's definitely got to be an antibacterial. Okay, so we have some new viewers showing up. May have missed the first part. So let me do it again. Here, look, you can see this is paper. It's sliding around. This is glass. We're putting the change inside of the glass. Let's go ahead and discontinue the ultraviolet radiation. You can see this is gravity, the pennies, the quarters, the nickels and dimes are all falling in here. I'm only doing this for fun because there are ways to make things stick to substances, but from an energy scientist perspective, do we have some phenomenon going on? No. It's not sticking to anything like glass. We pour it out. You can see the effects of gravity here. You can see that, some of the, these are old pennies, right? These are old pennies. They got dirty substance on it. You stick it to a wall. Oh, that one's sticking because you can see, look, it's got something sticky on it. And my hand is a little bit moist, has moisture on it, but here, let's just take this one here. Let's just do that. There, see, it's not sticking. And let me get this cloth. Let's just make sure that we're wiping the cloth off really good. I'm using my fingernail. See, it falls. So, is it sticking? No. they're not sticking. Here, let's take it just one step further. Let's do this. I'm gonna see if I can hold this here, and I'm gonna try to do something else. Like, 1 second. I'm gonna see if I can do something else. Like, if I can use something like a ruler here. Yeah, see, I pushed it with the ruler, and it did not stick with the ruler. So I'm going to see if I can do something else. Like, hang on. We're going to try to do something. Okay, so this is like, like the wood trimming of like a house or whatever. We're going to just try to see if we can, if I can hold this thing steady. We're going to just see if we can do this here. Get this in, bring it up. Here, hang on. I'm going to see if I can catch this. There, see? So the answer is the change sticking? No. Are things sticking? No. Like, are quarters sticking, dimes, nickels? No, they're not sticking. But you can see there was something very sticky on here. It did stick for a moment, but you can clearly see the sticky substance on it. So if somebody has dirty chains with, sticky substances on it, will it stick? Yeah, the probability is there. And that should conclude this video. So to so there is no question in electrical energy and science, plasma physics, okay, where you can take a copper tube and you can take a magnetic field if it's strong enough, like let's say like a neodymium magnet. You can, take a copper tube. Let's say that this glass is a copper tube. You can take something like a neodymium magnet. If this glass was copper, you could take a neodymium magnet and you could drop it down that tube, and if it's powerful enough, it'll stay suspended. It won't even go down the tube. It'll stay suspended in it if it's strong enough. So yes, there are magnets where if they overpower the amount of copper surface area, it'll stay suspended. So if you say, if the magnetic fields are strong enough, would copper stay stationary up against the wall? Of course it would. That's 100% going to mean that the magnetic fields that are present, if they're strong enough to overpower the amount of volume in these copper pennies, of course they could stay stationary on something. But if that were the case, then when somebody lets go of a penny, it would be like letting the magnet go inside of the copper tubing. It should be slowly descending. And why do I say that? I say that because that means that there have to be magnetic fields which are resident to be creating this phenomenon. And if somebody challenges that, it's very simple to come back and get the copper pipe, get a neodymium magnet, drop the neodymium magnet through the copper pipe, and watch how long it takes that neodymium magnet to go from the top to the bottom. And if it's the Gaussian field, the magnetic field is extremely powerful, it'll just stay suspended there. And I know, like, I don't really do too many more science experiments, but Joseph Newman already proved how to demonstrate anti-gravity. So the secret has always been in high voltage. But how he accomplished anti-gravity was by taking a large amount of copper and wrapping it around helium and running tons of high voltage through it. And then what would happen is the copper and the helium on the inside would create that repulsion that would let that tube float in the air. And I have the book. I still have his notes and everything that illustrate and show all of that. I just, after his partner died and I shared that information, I haven't been coming out and talking a lot about this stuff anymore. But look, the secret to everything is high voltage. And people still to this day, I don't know why they haven't figured this out yet. But look at the simplest thing. Aluminum sheets, like charges repel, opposites attract. Basic physics, two aluminum plates, run high voltage through it. What happens? What happens is when the electrons build up, the sheets separate. There's a repulsion effect, and the other sheets, they go flying off. So when you think about that, when you think about electrostatic charges, if you think about wire clouds with tons and tons, thousands of pounds of water floating up in the air, how is it possible? It all comes back to those charges, positive and negative, and how the dynamo of this earth works, ground, sky to ground. But I've been doing a lot of these experiments where I show the clouds, the cloud phenomenon, and we see what the clouds are doing. We see the patterns they're making. We can kind of see how they're rising and falling based on what the electromagnetic activity is between sky and ground. But here in Texas, where I'm at today, can we say out of a bunch of random change, copper, nickel, quarters, they all contain differing levels of metals in them. And as you can see today, where I'm at here in Dallas, Texas, we're highly irradiated with electromagnetic waves from tons and tons of cell towers. I've always known a lot of that content, even though it's locked now. But there isn't something, even with our 120-degree days of blistering heat here, we don't have change sticking to the wall. And I hope this was helpful. And for anybody who's seeking to get data into their catalog of, oh, does that phenomenon occur here in Dallas, Texas? The answer is, and this is raw, it's not edited, it's not anything, it's 100% raw, uncut, unedited, and there you go. So with that said, I want to thank everybody. Thank you, Mike, for all your inputs. I always welcome your inputs. You're a great guy. Love your content. And thank you, everybody else who's stopped by to see and experience this raw science experiment with change and this strangeness that's going on with TikTok and others. But yeah, I guess this is the part like where, we all try to help each other and try to understand what's going on. I do have something as a bonus to add tonight. Look, there's some other content which I posted on my wall, and I don't mean like this wall. I mean like on my channel in the post section of my channel wall. I posted a video where somebody was posting stuff that's going on with the sky, and they could see lots and lots of hexagons, everywhere. Well, obviously, a lot of my content is locked, but I did a lot of science experiments, and I showed a lot of people in person on video that there is a geometric movement of light. And how I explained it to everybody was, because everybody's talking about it, but nobody knows how to explain it and convey what's going on, but I can. And what is happening is light pressure. The structure of the light, the rays, the beams of light have changed. And if the atmosphere at its most minuscule microscopic level is in the shape, which the most efficient shape is the hexagon, is in fact making the light cut at certain angles and then beam down at the surface level. It explains a lot of things that we see. Materials were drying on different materials, like paint on the car, dust on the car. Like, there were these times when I would actually see the light, the power and intensity of the light coming down that was heating the cars was carving out hexagons. And when I say hexagons, I don't mean there's one hexagon here and that's the only hexagon. I mean, imagine somebody makes a net and they throw the net onto something, and every place where there's a hole in the net, the hole is a hexagon. And it's all uniform. It's all spaced out equally and the same distance within each other, but everything connects together. So there's like millions and hundreds of thousands of hexagons like everywhere. But when water, liquids, the dirt, and when I was looking at the grass and there were burn patterns in the grass from the sun, when you stare at the grass long enough, like staring at a 3D picture, you could actually see the rays of light that had singed the patches of grass. But all the patches of grass, if you look at it very carefully, were all in the shapes of hexagons. Like, if you looked at a yard full of grass, or if you look at let's say like a school's football field where it's just a big, grassy field, or a soccer field, right? It looks like somebody casted a hexagon net on the field, and you could see millions of tiny like hexagons singed in the grass where the sun had burned the grass. So that is something, to also pay attention to. So with a video that that individual posted, I made a post explaining that. If he wanted to get in touch with me and actually talk about it, we could actually talk about it. But this is all 100% provable. Now, what does it all mean? I don't know. But what I do know is I've been documenting the phenomenon. I haven't been talking about it, but I've been documenting it. But in the old days, I was talking about it, and the intensity has increased. So I don't know what's going on, but as time goes on and I'm documenting it, I'm really trying to be very observant and pay attention to everything that's going on. Does it have something to do with the way the water is disappearing? I mean, I have no idea, but I have something to say in regards to that. But I'm going to have to save that for another day. But this is where we are today, and I hope you found this helpful and useful, and I hope you liked this very basic and primitive and raw and uncut shadow burn style science experiment. And with that said, I want to thank everybody for stopping by. Godspeed. Hold the light for everybody. Cheers, and I hope to see you guys soon.